Hi everyone, in this video I'll be talking about applying recursion on arrays. It also forms the basis of a style of problem solving called backtracking. The simple problem that we are taking for this purpose is checking if some of the items of an array add up to a certain item. Take this example. If your array is 10, 50, 90, minus 90, minus 30 and 20, start is 0, target is 70, then we need to return true as the items 10 and 90 and minus 30 add up to 70. But if we have the same array and the same target and the starting index is 3, which means we can only consider items at index 3 and onwards, then you cannot construct 70 from these 3 items, and therefore this method should return false. If your array contains items 3, 8, 10, etc., starting index is 0 and target is 0 as well, you need to return true because the target is 0. So an empty array achieves that target, and an empty array is a subset of your array. Similarly, if your target is 23, 8 and 10 and 5 get that result, and some other examples. So recursion with arrays is all about backtracking. Let's take a simple example of an array. Let's say the array that we have is 12, 30, 7, minus 8 and 15. For the sake of convenience, we'll assume that starting index is 0, and let's choose a target, and let's say the target is 11. So what backtracking involves is just making a decision on whether to use the first item or not. Now, first item starting at index start. So there are only two options: either use it or don't use it. So I'm going to say use it is represented by a tick mark and don't use it with a negative tick. If you use 12 because your target was 11, then your target becomes minus 1, and then you look at 30. So with 30, if you use it, your target becomes minus 1 minus 30, target is minus 31, and you decide whether you want to use 7 or not. Then you got 7. If you use it, target becomes minus 38, and you check whether you use minus 8 or not. If you use minus 8, your target becomes minus 38 minus minus 8, which is minus 30, and you choose whether you use 15 or not. If you use 15, your target becomes minus 15, and you've reached the end of the array, which means that you cannot construct 11 by using all these items. So then we decide to not use 15, and your target is minus 30. So that's not good. So then you go back one level. So you cannot construct the entire target by either using or not using the value 15, which means that now you need to think about not using minus 8. If you don't use minus 8, your target remains minus 38, which was here, and you make a decision of either using 15 or not using 15. You can see none of these achieve your result. So then you choose to not use 7, and if you don't use 7, your target remains minus 31, and then you choose to either use minus 8 or not. If you use minus 8, minus 31 minus minus 8 gives you minus 23. If you don't use it, it remains minus 31. In this way, eventually you'll see that starting with 12, target target is 11, the current item is 12. You'll see that you will use the current item and your target becomes -1. 30, when we don't use it, of course the whole chain of using 30 finishes without success. But if you don't use 30, target remains -1 and the item is 7. If you use 7, target becomes -1 minus 7, which is -8, and the item that you have is also -8. And if you use that item -8, your target becomes 0. Now as soon as your item becomes 0, that gives us success. Eventually, if you explore all the options and you don't find any target or any set of items adding up to target, you can return false. So that's something we are going to encode into Java now. The first thing we do is we see if target has become 0. It means we have reached the success stage and we can return true without worrying about anything. One thing that you might want to do in the beginning is check if data is null, in which case return false. Let me add one case at the very beginning for null arrays. So whenever you call it with null array, it returns false. If target is 0, return true. If your starting index has gone above data.length, it means that you reached a stage where there's no more item left. And at this stage, you also know that target is not equal to 0, which means it hasn't been reached, so you can return false. Now our two-step process: use the current item and see if the target is reached. So the remaining target will be target minus data start. So after we use the current value, if we can construct the remaining target from the next item onwards, that's great. So if add up to same array but starting the next index, if we can construct remaining target, then it means that to that remaining target we can add the current value, and that will achieve my original target. I can return true. We'll only reach here on line number 50 if this function returns false. This means that target cannot be constructed by using data start, which is the current value. So the only option is to not use it. So whatever is the outcome of add up to data start +1 and the original target, so we are not using the current value data start. If it returns true, we return true. If it returns false, we return false. When I run this, my tests pass, which is great. It's always a good feeling when the tests pass in the first go. What I'm going to do is I'm also going to add a statement over here, system.out.println, trying to construct target using arrays.toString data starting at index start. So let's just see how these functions are called. When I run this and show the console, you can see heaps of messages. You can see you're trying to construct the original value This is for the function call at 60. 10 starting at index 0. If we use the 10, it tries to construct 0 starting at index 1, and my test passes. So whenever my test passes, I'm just going to also add a change of line so that it's clear that that test is over. And you can see my first test, which tries to construct 10 with this array, passes with 2 steps. My second test, where I'm trying to construct 70, you use 10 and it becomes 60. You use 50, it becomes 10. You use 90, it becomes minus 80. You use minus 80, it becomes minus 80 minus minus 90, which is 10. Then you use minus 30, it becomes 40. Then you use 20, it becomes 40 minus 20, 20. So when it reaches the end, using all the items, the total is still 20, which returns failure. So what does it do? It decides to not use the last 20, in which case it reaches the end of the array with residual 40. So you can see that in an array of 6 items, let's start with something simple. If the array has 1, 2, and 3 items, if the array has 1, 2, and 3 items, then there'll be 8 combinations. But if the array has n items in general, there'll be 2 to the power of n combinations of using those items or not. You can see that this value grows quite exponentially. If I have 16 items, it means 65,000 possibilities will be explored. If this number increases to just 31 items, the number of possibilities explodes to about 2 billion. So yes, it's not a very efficient strategy, but it is a very effective strategy in terms of exhaustive search. Thank you for listening to this explanation of recursion using arrays. A lot more questions are there on Coding Bat under Recursion 2 that you can practice. Similarly, we have also included a lot of examples and programs in our recursion practice package under Stage 4. So Stage 4 contains all advanced recursive methods. So if you take a look at Java practice package or week 6 practice package, recursion, attempts, Stage 4, it's binary search, fast power, fast Fibonacci, and there's an example, split 5-3 integer array data. So that's what we want in this array. All right, thank you very much for listening, and all the best with prac exams in future. Thank you.